Hey, hi guys, this is Vamsi. I'm back with another video. Today we are going to see the implementation part of linear regression. Previous video I have explained about linear regression in theoretically. So today we are going to see the practical. Okay, this is a simple linear regression, and another video I have uploaded about multiple linear regression also. Okay, first we want to input the libraries like NumPy, Pandas, MATLAB, lib. Okay, after importing, next we want to import the data set. I have show this is a data set which I have created by my own. They have a lot of errors, so please ignore that. For the this data set, I have used this data set for only for purpose of explanation only. Okay, and upload and project videos I have explained about the Kaggle data sets also. Okay, and next to go to the code, I have input the data set, and this is my df of data set. This is my data set which I have created my own, and df.head, I have used df.head for the top of the data set, top 5 of the data set, and that, whereas I use a tile for the down of the top 5 data set. It has occurred that like 30, 31, that these are the rows of the data set from the tail. And the describe, I have used a describe for what are the minimum maximum value standard deviation mean of the data set. For that only I have used this describe, and df dot max and max minimum we have already find in describe. Okay, again, like we can use this like this, or we can use describe for finding that. Okay, dataset dot info means for all information about the dataset, how much memory, how many columns, what are the null values is there, count, data type, memory, like that we can get information about that. And df dot date, df dot shape, this is used for knowing the how many records and features on the dataset, whereas 35 records and 2 features. We can know also 35 rows and 2 columns. This method is for finding null values, so we can use this method for finding the null values. So we have 0 0, no, there is no null values. Okay, now the pass x is equals to df dot I location. I have this, I have take hours on the x variable. For x variable I have take hours, so I have used this method for x variable, and y is equals to df dot I location for the score. Now I want to plot this x and y, like hours and scores, so I have used this method. Okay, for y variable I have take hours, and x variable I have take scores, and the figure size is equals to 8 comma 4. This is the length and width of a figure size. Okay, and scatter plot x, I am passing the parameter xy, and the color equals to green for this, and marker is equals to 0 o for round like this. Okay, and the next one I have used for sklearn dot linear selection. Now I have fit up to now I have scattered the plot of x hours and score. Now we are building a model. For that I am using from sklearn dot model selection import train speed test. For the testing and training it is used very full, whereas x test white and white test is equal to 9. I am passing the parameters xy, and test size is equals to 0.3, and random state is equals to 0. One from sklearn dot pre-processing standard scaling. And I am is there any different values in this x and train, x train, y train, x test, x train, x test? For that scaling, by the scaling standard scaling, I can make the values into scalar. So that's why I'm using this code. Okay, and the next one is I'm building the model from this, from sklearn dot linear model input linear regression. So I'm going into in this video I am explaining about the linear regression. That's why I have used this linear regression model. Okay, and fit the model. I'm the pausing the model rg equals to linear regression, and the fit regression dot fit extra environment. I have executed this. I have it's perfectly executed by predicting the values. Regression dot predicting x test I have used and predict the value. This is my output of the values. This is output of the values, and I can check the is this error is a lot of difference between this output value and y test. One more time, I am saying that this is an example data set which I created. So there is a lot of mistakes in this data set. So please ignore that. You can take another data set and implement the code like this. This code is you can available in GitHub. I have give that link in description also. Okay, and the next one I am whereas linear regression we can find the best fitting line by using y is equals to mx plus c. For that we are using the rg dot coefficient. We can get this and intercepted. This is a c, this is a m, and we are predicting up to 5. We can change this 5 to 10 also. Yeah, we can get this, and we can count like this. Y is equals to mx is whereas this is a m, this is a m, and this is a x, and this is a c. Okay, by using this 5 is equals to mx plus I have passed the 10 values. Okay, now we have to see the output. This is our 101.1. Whereas if I pausing the am, here the predicting of am equals to y. No, it's false. If they are equal, if they are get equal, so then it can be true. Okay, in this case it is false. Okay, the next one I am plotting the training data set where I have x train and y train. I am scattered the plot of x train and y train. Colors green, in color green, and the line width is 5, and I'm plotting the x train and predicting of regression that predicting x train. For the x train, predicting the x train rectangles. So color is equals to blue. This is a line, and the title is equals to linear regression, and legendary. For legendary means we can find this. For this we can get legendary. Okay, training and predicting. This is the figure size. It's a common. Okay, now execute this. Yeah, we perfectly executed. Like that only I have done for the test train also. Test size also for y test x test the same process, and I have executed this. And finally, this is a way of steps for implementation of a simple linear regression. We can implement in another way. Simply, I have to take a lot of steps to implement it. So once again, I am saying that this data set is not perfect. Please ignore that. It is created by my own. Okay. I hope you have understand about this simple linear regression. You want to get this code in the GitHub. I had uploaded in the GitHub. Please download there from there. Okay, for more updates about the data science, please follow our YouTube channel. Bye friends, take care. Like, subscribe to our YouTube channel. Bye.